Hi guys, we're back with our now unrepairable 8800GT, because if you've been watching the other videos you'll remember that the BGA reworking didn't go to plan, unfortunately, and we ended up with a lot of ripped pads here on the board. Ironically, the BGA didn't have any ripped balls on it, but it was overheated and kind of melted, really. Well, not exactly melted, but it was destroyed. As I just noted on the other video, it's not a coincidence that we have this big power plane here, coming into the BGA. This is one of the voltage rails or ground, and obviously this big power plane takes a lot of heat. And I think the reason I didn't successfully unsolder this one is because the largest top nozzle I have for my BGA machine is only just as big pretty much as the chip itself, and I needed to get a lot more heat into this area. So what I'm going to do now, I'm going to speak back to LY who make that machine, and ask them how much for a larger nozzle. I think maybe that was a 41. I think if we get a 50 or thereabouts millimeters square, that'll give me another sort of 5 millimeters either side. Maybe get a 55, something like that. Then it's going to be easier to work on these things in the future. So anyway, this is the one that is basically no longer repairable. And if you watched the last video, I said what we were going to do is we were going to remove the EEPROM chip from this one, and we were going to see whether put that into an EEPROM reader and programmer, and see whether the contents of this EEPROM are the same on the other one, the one that just hangs the PC, that isn't detected and stops the PC from booting. So to do that, first thing we have to do is to take this chip off. Easiest way with this one, and especially considering we're not really too worried now about this board, because it's basically scrap, but we're going to, before we do scrap it, we're going to see what parts are useful to take off that board to keep ourselves in stock, because we know most everything else, the power supplies, the MOSFETs and such like, capacitors, if there's any useful ones, are good. So let's have them. I'm all for stripping parts off boards and using them, if especially if I know that they're good. Okay, so easy way for this, got the quick hot air on 450, and I'm just going to warm this bit up here until it unsolders, and it shouldn't take too much to do that, he says, but obviously there's fairly heavy ground planes on this. Let's just warm around this area and we'll come back onto the one that we want. Not wanting to give it up just yet. Okay, it's been a little bit more troublesome than I expected. There we go. So we now have the EEPROM from that board. We looked at that EEPROM earlier if you watched one of the early videos, we know what the part number is. It's MX 25L1005, and here it is, nicely desoldered, yeah. So what we'll do with this one, first of all, let's put a little, let's mark it so that we know this is the one from that particular board. Because as I've mentioned before with this sort of stuff, it's not difficult to get yourself confused, and you forget which one's which if you tick off the other board. Easy with this, probably just put a little scratch mark on it there. Yeah. So a little scratch mark, we know which one that is. Okay, so that's the EEPROM. So we need to read that first, and then we'll take the EEPROM from the other board. In fact, no, let's take the EEPROM from the other board now. We've got them both, and then we'll read them both and compare them to see if there's any difference between the two. This one, because I'm hoping this board is something I can repair, I'm going to do this one slightly differently. I'm going to use the hot air again. But what I'm going to do with this one, I'm going to add a little bit of leaded solder to that ROM chip before I desolder it. That will help with melting the solder basically. Leaded solder has a lower melting point than lead free, and when you effectively mix the two together, you reduce the melting point overall. You get like an alloy of leaded and lead free. So let's just see if we can actually get a bit of. I'm going to use the microscope myself for a moment. It makes life easier for me. Let me just get in here. Let's just look through the eyepieces. So I'm just going to get a bit of solder down there on each of them, yeah? And the same this side. Let's just, yeah, it's backwards a bit, but okay, I've got a bit of solder on both sides of that, yeah? And that, with a bit of luck, will make this one a little bit easier to unsolder than the other one was. So once again, we'll get a bit of hot air in on here. We'll warm this area up. And we'll unsolder this one. Yeah, that one came off quicker. I'm sure you saw that. And the hot air was on the same temperature. But you can see that by doing the little trick with the leaded solder, that one definitely came off easier, yeah? Okay, so we now have the two chips. So let's have a look at the EEPROM programmer. Let's go over to the other camera. Okay, it's not my bottle of water for drinking, by the way, it's for wetting the sponge. Okay. So let's see what we have. This is my EEPROM programmer. Mini Pro. It's a what do they call these things? TL866A. This is the CS version, which has a little header in here. And the idea is you're supposed to be able to program things in circuit with this little lead that plugs onto there, yeah? So you can take the lead off here and plug it into here, or you can put it onto a header and put this on here. The problem with programming in circuit, although it seems like a great idea because you haven't got to unsolder the chip, it rarely works. I mean, basically, this programmer would have to power up the ROM that you want to program, yeah, and also power up anything else that's connected to that voltage rail. And generally speaking, it can't. So I rarely use this. I've tried and I've failed to actually clip this onto the ROM once it's desoldered and plug this into the reader, and I still can't get an accurate reading from the chip. So this comes with all these wonderful little bits and bobs, yeah. These are different sort of chip holders for different types of EEPROMs. This is the one we need for this. So this little adapter here, yeah. And let's see if you can see on that how well will it focus. Notice how it's strange how the camera flickers when I put my hands up there. Stop it. I don't know why I stopped making it do that. Stopped it again. Yeah, so basically what you have to do is this clips into the EEPROM programmer, and you have to solder the ROM chip that you want to read or program onto the little pads here, yeah. It is marked. Let's see if you can see it. Yeah, you 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So 1 goes to the top of the programmer. Yeah. Can be a little bit fiddly to get in because of this handle. I've noticed, but anyway, yeah, we're in, and we're now on there. Yeah. And you can now solder your chip onto here, the EEPROM. So let's look at first the one we removed from the now trashed board. Again, this is quite nicely marked for you. So there's a little circle symbol here. That's pin 1, yeah. And I find it easier to stick this on the program and then solder the chip, because it stops this thing like wobbling around when you're trying to solder on it, yeah. So I also find the easiest way to do this is through the bench magnifier, because I don't think my microscope will actually focus on it when it's this high up. Let's have a look, because it would be easier to show you under the microscope. Let's see if we can, without physically moving the microscope higher. Let's see if we can actually get a focus on this or not. Oh yeah, maybe. So if we go a bit higher up. Hey, we're in luck. We're in luck. So you can see this adapter's been used a few times, yeah. This is the little little circle I mentioned here, yeah. And that circle is pin 1 on the chip. And if you take the chip, pin 1 is where the dot is, yeah. So it's upside down. So we need to turn this round on here until we get it the way we want it to. And solder it on. Easy way I find with this is literally just to hold it in place. Often with my fingers, I can do this. You'd think with tweezers, but I can often do this just like this without burning myself. Sometimes you have to like remove a bit of solder off those pads just to get it level. Okay, if we go like this, yeah. And I'll try not to burn myself, obviously. Bring the soldering iron in. And I just want to... No, I moved it, didn't I? This is because I'm trying to look at the screen. I'm not looking through the microscope. Just one moment. Let's make life easy for myself and get down the lenses of the microscope again. Okay. Well, I've actually managed there to just tag that leg, that first one, on a little bit. And now you can see if I just hold it with my finger against the other end, I can actually hold this in place. And what we can do is now is we can come in and just solder the other legs. Oops. Yeah. I've got it now. Let's add a little bit of solder, and let's add a little bit of the take a bit of the 0.2mm wire because it's easier. So solder. And we're just going to tag this on. Again, you see I'm doing this with a big chunky tip. I could change to a smaller one, but maybe I do need to. You know why this is not soldering, don't you? Do you know why? Begins with F. That's why it's not soldering. Yeah. Get in here again. If all else fails, I have to put a small tip on the soldering iron. But with the addition of a bit of flux, it probably isn't also well because heat's conducting back down the legs into here, but I don't think that's enough to affect this. I'm sure we can get that onto there, yeah. That's looking good enough to me. Okay, let's spin it round. And a bit of flux on the other side. You have to appreciate with this sort of work, you know, programming EEPROM isn't like 5 minutes job, it's like 25 minutes job because you have to do this first. Okay, the ones and sockets make life a lot easier for you, but you know, sometimes people weren't setting out to make your life easy. That's looking good to me. We can double check, you know, just to make sure that we have actually got a good connection on here. And if you've watched me by now, you know I like to double check things to see what we have. So you don't need to see the test meter because you'll be able to hear it bleep, won't you? Yeah, you can hear that, can't you? So we can just double check. Again, I'm going to do this through the microscope because it's easier for me. From the pad to the pin, yeah. Looks like I don't have that one. So this is why it's worth doing this. Okay, so we can see we don't have a solder connection on one of them, and we need all 8. So let's just come back and do this one to be sure that we actually have a connection in here. Okay, once more. Do we have a connection now? Yeah. That one's good, yeah, they're all good. I'd mention the others. Okay, so we now have an EEPROM. Let's go back to the other camera. There we go. My desk is now getting messy, and now I hate mess. You know, actually, I'm not the most tidy person in the world. You ask the missus, you ask my wife. I'm not the most tidiest person in the world, far from it. But when I'm working on this sort of stuff, yeah, then I am. Okay, so this is EEPROM Programmer, and it's quite a simple device. All we do is connect the USB to the computer, yeah, and then we'll go to the desktop and we can see what we have. Okay. So, this is the software, Mini Pro, and the first thing we need to do is put in the chip number, yeah? So you can see here the last thing I was programming. So it was a 25L, it's actually a MX25L, well, I probably don't need to put the MX, if it doesn't find it, we will. 1005. 295, oh, Macronic sounds like MX, yeah, there we go, MX. And it gives us various pins here, SOP 8, SON 8, and this will be like the actual package size. I think this is SOP, but let's have a look. We can easily do this. We can just go on to Google and just put SON 8 package and see what one looks like. No, that ain't it, is it? That's not the chip we have. Must be the other one. Must be the other one. SOP 8. Yeah, that's the baby. Okay, so we know it's a SOP 8, so we can go in there. Macron, it didn't have a letter A after it, so it's not a KH, sorry, it's that one. 1005 SOP 8. So we'll choose that. And then what we'll do is we'll tell it to read the chip. Now it should look for an identifier on this chip and say if it's the right one. Read. Yep. It said there ID C220110K. This is each of these EEPROMs has an ID number, and when it reads that ID number tells the programmer that is the type of chip. So we know we've chosen the right one, yeah, and we've now read the file. Occasionally you have to override it if it doesn't quite read it. You know, there is a case where you need to override that auto thing, but in our case it was good. So we cancel that, and now look, we have, oh, we are IBM VGA compatible. The date, yeah, 2008. The version, telling us a bit about video, yeah. Well, you know, there's all sorts of text in here, tells us about the board. And then this is the actual BIOS code. So we've read the BIOS out of that one, and we know that one came off the board that's now scrap. So the board that is now a component, don't it? Yeah, sounds much better, doesn't it? So what we'll do is we'll save that one. And we'll call it 8800 GT donor. Yeah, and we'll save that file. File save. So what we need to do now is go back and check the other one. So here we are, back onto the microscope. Let's just go to the software. Go back on the microscope, which is now crashed. I don't know why my microscope camera keeps doing this. I've got a new camera coming, by the way, for the desk, a much better camera. So I'm hoping that once we now it's good. I'm hoping that once we fit the new camera, I'll be able to focus much better on things over the desktop. And I also have a zoom on that. It's a zoom lens. With manual focus, I can get the focus right. Okay, so we've done this one, yeah, and we want to take that off there. How we're going to do is, I think, hot air to take it back off again. Just stick the thing down here. It's leaded solder, so this should come off here quite easily. I don't want to do it on the program. I don't want to melt the programmer, yeah. You can't see this, I'm sorry. I'm sorry I'm off camera, but it's too bloody hot now to move it, okay. Or maybe we do it that way. Maybe we can, maybe we can't. Yeah. Maybe we can focus it, maybe we can't. You know what it looks like to hot air unsolder things anyway. That's off, yeah. So that's the one that came off the other card. Right. Let's put the other one on here. I'm going to do it the way I did before. I'm going to put this back on the programmer. Keeps it. It's not too hot now. Now, so that keeps it hot while I'm keeps it stable while I'm soldering. Yeah. Again, the little circle is pin 1. So this is our other EEPROM. And we're going to stick this on here. This is still quite warm, so it should be quite easy to solder this. Let's do it the other way this say without risking burning the fingers. Without burning my fingers, although I didn't burn them last time. I've just tagged one of the legs in position now. Now I've got one leg. I can just literally move this. I'm going back into the lenses again. I find this. I mean, I can do it on the screen because I was just doing it, but it's much easier for me to do this. So I've tagged one on. Yeah, they're all in line now. So let's just come along here again, and let's just fit this other EEPROM on here. Okay. Tagged in. You'd be surprised what you can do with a big chunky solder iron, you know. In actual fact, there's a lot of advantages to this. It transfers heat much better into the solder joint. To be honest, you remember that HDMI connector we did with the damaged tracks on the board? And I did it with a smaller bit, but actually that would probably been easier to do with this. Yeah. You don't need a fine soldering tip to do fine soldering. And if you doubted that, well, you've just seen, haven't you, again. Same thing, let's get the test meter. You can hear the bleeper, so we don't need to worry about you'll be able to see the dial. Yeah, I hope you can hear that. Just check we have a good contact. Yeah. 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 Yep. 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 Yeah. That's a good one. Okay, so we're back on the programmer. Let's go back to the desktop and let's try and read this one. Okay, so we don't need that. We don't need that. We should go to the desktop. Yeah, there we go. So this is our program again. Yes, we've read the first one. So what we're going to do now is we're going to read this one. Author read. Yeah, you recognise the chip, okay, and it's read it. Done. And we're going to save this file now. Again, so file, save, and this one we'll call it 8800. Good. It isn't a good board, but donor and good. You know, as long as we know what we mean, it doesn't really matter, does it? So we'll save that. Yeah. File saved. I'm just going to check. Stupid thing. Where's it saving them to? File save. Oh, I see. They're going to some last folder I was using. Electronic Canary. Yeah. PM something or other. I'll find it. I'll find it. Okay. So we have the two files. So what we're going to do now is we're going to compare these two files to see if there's any differences between the two. What software can I use to do that with? I'm sure I downloaded something to do this with. Let's see what we have in here. Like a compare type thing. I'm sure I had something. 1 second. I'm just going to pause the video for a second while I figure out which software I need to be using. Okay, guys, I found the software. It was here all along. This thing, ExamDiff Pro. This is one I use. It's free software. So let's have a look at these two ROM chips. and see where they are. I've just found them already for us to check this was the right software. So we have 8800 good and 8800 donor. Those are the two files, yeah. And we're going to now just, I mean, basically this is simple. You just find the folder, yeah, and you just find the file. I mean, I'm sure I don't need to teach you how to do this stuff. If I do, okay, that's how you do it. You click the folder, you find the file. And we have the two files that we want to look at, and then we hit compare. And it says they're identical binary files. Okay, they're good. Well, they're good. It says they are the same. So from that, we can assume, really, that they're both good, because the chances of you finding two EEPROMs which are faulty, but corrupted, and they're both corrupted in exactly the same way, is, I think you'll agree, like none. The chances of that, you're more likely to win the lottery, I would say, than that to happen. I don't know what's wrong with my camera today. Sorry. There we go. Yeah, so we now have two ROMs which are identical. So we can say with very good confidence that the problem with the one that just hangs isn't the EEPROM. So next thing with this one would be to, we'll resolder the EEPROM. We will try to reflow this. You know the trick where people stick them in the oven. We're not going to stick it in an oven, but we're going to put it on the BGA rework machine. And I'm not going to resolder it and reball it. And I'll tell you why. Because I haven't got a stencil for these GPUs. And I've had a look on AliExpress, and I couldn't find a stencil for these GPUs. And for the amount of effort to reball a GPU without a stencil, to do it manually, it's doable, And if I've just found myself, like, a 500 quid GPU and it cost me 10, and I need to reball it, I'm going to do it. But for this, nah, it's not worth it. You'd be better just to buy a replacement one. So anyway, let's see. Let's put the EEPROM back on, and then we'll try and rework this one so reflow this one. We'll put flux under, and we'll get it to the point where the solder balls melt, but we won't try and remove it. And let's see if that recovers this card. Okay, guys, see you on the next one.